Okay, so in this video we're going to look at two types of sequences. The first one being what is known as an alternating sequence. All right, now when we say alternating, what we're referring to is the sign of the terms. All right, in our previous video, we strictly had values that were positive. Right? Now we may have negative values that turn into positive as the terms of the sequence progress. But for an alternating sequence, we're strictly looking at something that looks like this, where we have a sequence that alternates in sign. Okay, now we can take the sequence that we looked at before and do the same thing to that, right? We took the nth term and we squared it, right? 1, -4, 9, -16, etc. Okay, now the way we can achieve this, we can almost think of the alternating part as like a separate thing, right? We have the sequence, right? We have the explicit formula for that, and then we can multiply in the alternating part. Right, now the best way to do that is really by this number 1, right, and raising it to a power, right? Since our domain strictly deals in integers, right, the power of -1, right, is always positive or negative depending on whether the exponent is even or not, right? So -1 to the first power, that's -1. -1 to the second power, that's 1, right? And then -1 cubed, we're back to -1, right? So odd values will give you a negative sign. Even values will give you the positive one, right? So we can move forward by doing, and you can always kind of, here you can write it, for instance, here our sequence. Here we can write the explicit term to be just -1 to whatever n is, right? If it starts off, and actually here, since it starts off positive, we do have to be careful here. One way we can kind of shift the terms is by adding 1 or subtracting 1, right? But now if we add 1, right, a1 starts off as 1 plus 1, which is -1 squared, which gives me 1. Okay, so that gives us a way to start off with a positive. I want to start off with a negative, so let's say I want to start off like this, in which case we can simply start off by -1 to the n, right? So as soon as I plug in 1, I start off with a negative, and then I alternate from there, right? Negative, positive, etc. Right? So for example here, this formula, let's say I wanted to write the explicit formula for this one. Okay. All right, and in this case we have, so I know from a previous example that it was this, a sub n is equal to n squared. Right, but now I want to get it to alternate, right? So like I said, think of this alternating as two separate parts. You can figure out the calculations for the numbers, and then the alternating part you can multiply in. So -1. Now be careful here, since n takes on the value of 1 or bigger starting at 1 for n being an integer. Z, this fancy Z here, is telling me these are integers. Okay, so if we want to do that, right, if I want to make sure that I start off with positive, then I'm going to write n plus 1 or n minus 1 would get you the equivalent expression that you want. Right? So now when I plug in 1, I start off with a positive value, and then it'll alternate between positive or negative. Okay. All right. Now let's do an example. Right? So here in this example, I would like to write the first 6 terms. of the sequence. And let's do 5. Let's say an equals to 4n over negative 2 to the n. Right now, here it's written in a form where it doesn't have the kind of negative 1 here, but actually it's in there, it's just kind of hidden. I can rewrite this as negative 1 times 2 to the n, which again I can, using powers of exponents, 2 to the n, right? And whether I'm dividing by 1 or multiplying by 1, it's the same effect here, or negative 1. I can simply write this as 2 to the n. All right, and here I want to write it like this just to keep with the same kind of format where I have the alternating part, right? That negative 1 to n or n plus 1, whatever it might be. You can think of that, oh, that's my alternating part, right? That's what makes it change signs. And then the other part is just the other part of the sequence, the one that gives me the value of the number. All right, so if I want to find the first 5 terms, again, start off counting from 1. So we get negative 1 to the first power, 4 times 1, 2 to the first power. So here we're going to start out with a negative. 4 divided by 2 is 2. So we get negative 2. So a2, we get negative 1 squared. 4 times 2 over 2 squared. So here we have 8 over 4, which gives me a positive 2. Okay, and then moving along here, our third term, we have negative 1 squared, to the third, 4 times 3 over 2 to the third. So we'll have negative, and what we got, 12 over 8. We got 3/4. Okay, and then a4. So here we have 16, and here we have 16 as well. So we'll have 1. And then lastly, our fifth term, negative 1 to the fifth, 4 times 5 over 2 to the fifth. So we'll have a negative value here. And then here we have 20 over 32, which reduces to 5 over 8. Okay, and that is a negative, right? Alternating. Okay, and that is how we evaluate that alternating sequence, right? Again, you don't need to do this step where you have to write it, the negative 1 to the n, but it's just a nice visual representation when you can think of this, oh, this is alternating. I see that negative 1 to that n power. Okay, now our second type of sequence that we're going to be looking at, so alternating, the second one is what's called a piecewise explicit. So we have a sequence where we are given a piecewise explicit formula. All right, so let's say, for example, we want to write the first 6 terms. Of the following sequence. Okay, so we got a sub n, and here we'll have 2n cubed if n is odd, and 5n over 2 if n is even. All right, now when you evaluate for a particular n, you're not going to have 2 different values for that n, right? We need to make a choice, right? Much when we had piecewise functions, right? We made a choice as to where we evaluated. Again, this rule here is a rule on the domain, right? It is telling me which piece to use, right? I can only use one for each value of n, right? Either 2n cubed or 5n over 2, depending on the rule, right? So if we go ahead and say, all right, so let me start, I'll evaluate a 1, right? Well, is 1 even or odd? It is odd, so I will use 2n cubed. So it'll be 2, which gives me 2. And then the second term, go a2, right? So here, that is my n is 2, and that is even, so that means that I would write it here. So that gives me 5. Right, and again, moving along here, a3. Again, 3 is odd, so it'll be the first piece here. 3 cubed. 3 cubed is 27. 2 is 54. Okay, and then here a4. And 4 is even. So we go 5 times 4 over 2. So that becomes 10. And then a5. Again, each term, right? Notice we're only using one piece, right, for each value of n. And as 5 is odd, so we get 2 times 5 cubed. 5 cubed is 125. You double that, you get 250. And then lastly, the sixth term, we're back to it being even. So we get 2, 6 cubed. Let's see, 6 cubed is 216. Oh, hold on. See, I messed up here. Odd. It's going, 6 is even. It's going too fast here. 5 times 6 over 2. So 30 over 2 is 15. Okay. All right. And that is how we would approach a piecewise explicit formula. Okay. Pay attention to the domain restrictions, right? This is telling you which one to use for a particular value for n. Right? Notice that for each value of n, it's only one output you get. Okay.